Well, good morning. I'm Ken Biberaj, and welcome to Coffee with Ken, a thought leadership series at the nexus of business and politics. We are live here in North Carolina at the Research Triangle at the pilot facility for Vulcan Elements with CEO John Maslin. Good to see you, John.
Yeah, thanks for having me.
So why should folks care about magnets?
Why should folks care about rare earth magnets? They are ubiquitous in our economy. They literally turn electricity into motion. Motors, sensors, actuators, generators need them. What does that actually mean? Everything from your cell phone vibrating to a hybrid and electric motor to an F-35, a ship or a submarine. They are foundational to our economy, and they're going exponential over the next 25 years.
Amazing. And I want to dive in a little bit into your personal background. So you come to this company as CEO, having served our country in the military, having worked in defense, having gone to Harvard Business School. Tell us a little bit about your background and what pulled you, no pun intended, to magnets.
Yeah, good morning. So my background is 6 years active duty in the United States Navy. I was stationed for almost that entire time in Washington, D.C. at Naval Reactors, the Navy's nuclear energy program. Did a lot of work understanding our own supply chains, understanding how do we actually take a taxpayer dollar and create an application or a system that the warfighter can use to protect the homeland, to go and do the work that the Department of Defense needs us to do every single day. Got out a couple of years ago, went to Harvard Business School, and was really looking at three fundamental supply chains that are going to define the 21st century. Semiconductors, batteries, rare earth magnets. Those are
Semiconductors, batteries,
rare earth magnets. Those are the three critical components that virtually every electronic needs. And the way that I personally like to think about it is, if you think about your own body, a semiconductor is like your brain, a battery is like your heart, and a rare earth magnet is like your spine. It converts electricity into motion. And as I was thinking about the next generation technologies that will, again, define the 21st century, that will take us into the future, whether that's AI or drones, hybrid and electric motors, or robotics, I realized that everyone was focused on semiconductors and batteries, but people weren't paying attention to rare earth magnets. It's a three-legged stool. And today, China produces over 90% of the global supply, and the US produces less than 1%. And if the United States and the West wants resilient supply chains that allow us to actually build the technology that allows us to lead the future, we need to make sure that we have all of those supply chains onshored, in-house, producing at capacity.
So tell us a little bit more about what that supply chain looks like from a kind of mining to a manufacturing kind of narrative, right? So China controls, 95% of the actual refining and processing, but where are they sourcing it? Where are we sourcing it? How dependent are we on factors we can't control?
Yeah, so one question I get a lot is this a geology problem? Do they just have all of the rare earths? And the answer is no. Today, China produces they mine about 55 to 60% of the material. But to your point, this is really a refining and manufacturing problem. They manufacture over 90% of the magnets. And maybe just thinking about mine to magnet or recycled material to magnet, what does that look like?
Yeah.
Basically, what you have to do, either in the United States or Canada, Brazil, parts of Africa, Australia, is you mine that material or you recycle it. It's in a concentrate. All of those rare earths and other products are clumped together. You then have to separate each individual element to create a separated rare earth element. Neodymium or dysprosium, we can get into individual details if you want.
Yeah, I do.
You have to take that separated rare earth oxide, strip away the oxygen, and turn it into a high purity metal. You take that high purity metal and you alloy it. So you take the rare earths, iron, boron, and you turn that into a very thin alloyed flake.
Because that's what will go into a fighter jet or into a new technology, right? It's not going to be the clump.
Almost, yeah. So effectively what we do is we take that metal, we turn it into that flake, and through a series of processes in this facility, we turn that into a finished magnet that can go into an F-35, or it's what allows your cell phone to vibrate.
Yeah. So let's talk about the trajectory of Vulcan, right? So a year ago, you were graduating Harvard Business School, if I'm not mistaken?
Yeah.
Okay, and now here we are in a 20,000 square foot R&D facility where you're actually engaging in having conversations not only with defense entities, but also commercial prospects and clients?
Yes.
So what has this last year been like for you, and how fast has this kind of process been for you?
So we actually started the company while I was at business school because we knew that we needed to onshore this capability as quickly as we possibly could. So we took our first check 18 months ago. And in those 18 months, my co-founder and I, he has a PhD in electrical engineering with a focus on magnetics.
Who you met at
Who I
school?
met through a classmate at school. We went to the Department of Energy and with their scientists validated our own chemistries. We made magnets ranging from defense grade down to consumer electronic. And then what we did is we said we need to go and find a pilot facility, a first principles facility where we can understand every variable at every step, because that's what allows you to actually get to the commercial scale that is required in the West. And so over the last year, it's been finding the right facility in the right location, building out an incredible team, and getting all of the equipment, understanding our own supply chains. And we opened our doors March 31st of this year, and we're already producing magnets.
That's incredible. Not only do we drink coffee, but I also spend time doing site selection, traveling the country, meeting with companies like yours. And it feels like this is a true moment in a manufacturing resurgence in the United States, a real realization that we need to strengthen our own supply chains, not only for consumer products, but also from a defense national security process.
Yeah.
And so many new companies like Vulcan seem to be having direct conversations with Washington. Talk a little bit about like federal engagement. You mentioned the Department of Energy. How are you liaising with government? How important has it been for you to kind of have that active communication as you think about growth and scaling and meeting future demand needs?
Yeah, so what I would say is Washington gets it. Congress understands, the Pentagon understands. It's now become an issue where it's not just a subset, but everyone understands the importance of onshoring and being able to actually manufacture things in this country. So we've talked to people across the gambit, DOD, Department of Energy, Commerce, Trade, the Hill, and the support's been overwhelming. People want companies making things in this country. They want to support us however they can. And so it's going to take an industry and government approach to actually get this right. We want, candidly, as much competition as we can get in this country. That's what makes the United States such a special place, is you have multiple companies who are innovating and who are trying to actually gain trust of customer, create really quality, high throughput products. And that's what allows us to have the economy that we have today.
How has the reliance on China been amplified in light of tariffs, trade wars? I think on April 4th, they started restricting the sale of magnets to the United States. Like, how disruptive has that been? How worried are you about the need to kind of accelerate your own work and innovation here?
So we opened this pilot facility on March 31st, a Monday.
Yeah. And on a Friday.
And on a Friday, that export restriction hit. So the amount of customer interest across defense, aerospace, critical economic industries, anything that needs a magnet, it's been overwhelming. I mean, companies understand that they need resilience within their supply chains. And so we're going to go and scale as fast as we can. We want to hurry without rushing. And what I mean by that is this is not buy equipment, press a button, make a magnet. This is complex, advanced manufacturing. And if you don't understand every variable, if you don't understand that you have to take the data and structure that data and use it and learn with 2025 tools, understanding AI, understanding how to use large language models, understanding how you can actually automate at scale, it's not going to work. So we're moving as fast as we can. But we're also making sure that we're building the infrastructure and the base that actually allows us to go and exponentially scale over time.
How many competitors do you have doing what you're doing in the United States today?
There are only a handful.
Yeah.
And frankly, if you combine all of our competitors together with us, we still don't meet full US demand today. And so we need, again, a robust and healthy landscape across the entire supply chain of companies that are trying to separate and make rare earth metals and make magnets, because that is the only way that the United States and the West, and when I say the West, I mean that broadly. That's the only way we're going to be able to compete over time. That's also the only way that we're going to be able to ensure that we control the most important technologies that our grandkids are going to rely on.
So right now we're dealing with China kind of controlling the valve of access to this critical mineral, to rare earth magnets. we've seen this with lithium, where the price of lithium has plummeted at a time where we're trying to boost domestic lithium production and mining because China floods the market.
Yep.
Is there that kind of concern on your end where you can get up and ramping and then there's a flood of sheet magnets? How do you kind of hold the course against geopolitical tailwinds?
So what I would say, even outside of the export bans, if you copy and paste what China is doing into the West, it's not going to work. You can do the most basic techno-economic analysis that you can possibly think of. And when you think of labor costs, when you think of environmental regulations, it dissolves immediately. So the answer is we need to find ways to do this better and smarter. The intent of Vulcan is not to be an alternative to China that is multiples of costs more for the same product. The full intent is to leapfrog.
Yeah.
And that's what we're doing every day is we're finding smarter, faster, cheaper ways to actually produce, which is why this pilot facility exists.
So the United States used to be good at this, right? Of manufacturing magnets, like in the 70s. Then we kind of pioneer a lot of this advancement in this technology, and then we kind of just outsourced it like everything else in our country, right? And this is kind of a second chapter, if you will, on American magnet manufacturing.
Yeah, the general rule of thumb is, the US and Japan co-invented neodymium iron boron. And it was actually in the 1980s, General Motors, they're the ones who commercialized this at scale. There was a lot of magnet production in Indiana. The United States was the premier manufacturer of magnetics. Two things really happened in the 90s and the early 2000s. One, you had tailwinds for globalization. China was the world's manufacturer. They were cheaper. And the second thing is the Chinese were really smart and they were strategic. They don't operate on 4 or 5 year time cycles. They operate on 50-year time cycles. And so what they said is, we want to be the critical component manufacturer for the next generation of our economy. And so what they did is they subsidized critical minerals. So think batteries, think rare earth magnets, and they made the economics extremely difficult for anyone outside of China to produce.
And they're either mining it within China or elsewhere in Africa, and they're controlling the kind of access to mining as well?
Correct. I mean, today, they mine 55 to 60%. They manufacture over 90% of the magnets, right? So that delta, they're importing from the rest of the world. They've been very aggressive on trying to go and capture mining assets outside of China. But if you really know where to look, you build trust and credibility, not just with miners, but recyclers. Today, only 1% of rare earths are recycled.
Yeah.
It's not there yet, but it's getting there very, very quickly. You can get the material that you need at scale from the US, from our allies, in a very transparent, resilient way.
So tell us a little bit about the space we're in, around 20,000 square feet, what's happening here today, and where's Vulcan going to be in the next year?
It's a great question. So this facility is our pilot facility. This is where we are making our magnets. Essentially, we take those metal inputs, we turn them into an end magnet. Every part of this process is running every week. We are already making our initial batches of magnets 9 weeks after opening the doors. The amount of pre-work that was required to actually do that was phenomenal. To make sure that when we got the equipment, it actually turned on. And that's really a testament to our team, our engineers and our technicians. What we're going to be doing over the next year is we're going through the tedious, hard work of understanding every variable at every step. There are different grades of these magnets. Some are lower energy density with lower temperatures. Some for defense and critical economic applications, very energy dense, they're very strong, and they have very high heat tolerances. And so what we're doing is we're actually building out our portfolio of every different grade of magnet with data sheets that we can provide to customers that allows us to say, this is your demand, this is your volume, this is the spec. We know exactly how to do that, not just one time. We can do that hundreds, thousands, and eventually millions of times because we understand the recipe, we understand every step of the process in a very real way. We've structured that data and we understand how to actually leverage that to move faster.
Wow. And where do you need to be in the next year, 2 years, 5 years to meet the demand in the United States for the technology you're creating? Like, how much bigger does this facility need to be? And how much pent-up demand are you already hearing about?
This needs to be 15, 20 times bigger. We need to get to the thousands of tons of production immediately. Is that going to happen overnight?
Yeah.
The answer is no. Again, this is not, you don't press a button and make a magnet.
Yeah.
You need to actually understand how to do this the right way, which takes time. In 2 years, we should be in the several hundred, if not, over 1,000 tons in 5 years. The intent is for Vulcan to be the largest magnet producer outside of China in the world. That's actually filling an important mission for defense, for aerospace, for robotics, and drones, and cars, and data centers. So we need to move very, very fast. But it all has to be rooted in first principles understanding of how powder metal actually works.
Yeah. So tell us a little bit more. I've heard you in other conversations talk a little bit about being mission driven. How important is that to your ethos personally, creating the company, into Vulcan itself, and just the message you want buyers, consumers, the public to understand when they think of Vulcan Elements?
This company is built for America and its allies. If the United States and its friends cannot figure out this supply chain, we lose. And I mean that earnestly. I'm having my first kid in a couple of weeks. What I do not want is to look at her in 20 years and shrug my shoulders and say, hey, I wish I would have done more. A political comment, but I think Marco Rubio nailed it when in his confirmation hearing, he said, if we don't start making things in this country again, in 3 to 5 years, we're going to have to ask China what we're allowed to build and what we're allowed to buy. This is fundamentally a mission. Like, yes, the economics are great.
Sure.
Yes, there is huge and overwhelming demand. That is second to actually making sure that we fill an important gap in our supply chains so that the U.S. can be what it has been for the last century.
So is that the time frame in your head, a 3 to 5 year horizon, to really accelerate our own kind of reshoring, strengthening the supply chain, domestic manufacturing?
The answer is yes. If we can go faster, we will. I think that especially in this supply chain, with the complexity of the equipment, with the complexity of making sure that you have the right suppliers at scale, it's going to take a couple of years. If anyone says, hey, we can do this immediately in 12 months, I would say, show me the data. We're going to move as fast as we can, but this isn't just about having the capacity.
Sure.
This is about making sure that when I give you a magnet, customer X, it works. And that's where I think execution is everything.
You got to go slow so you can go fast, real.
We say that every day.
Yeah. Interesting. So as you look at your role in this kind of conversation ecosystem, I feel like there is a kind of gap between the general public's education and understanding of the importance of magnets, right? Like, I think we've been, all led to kind of understand the need for chips and semiconductors around the diversification of battery technology. Magnets is kind of that third one that, as you mentioned. How uphill of a battle, how much of your time are you spending educating either policymakers, business leaders? How does this education kind of need to be shared more broadly?
Customers get it because they buy them every day. The government, there are pockets of government that understand it deeply. Getting the majority of folks to understand that's the problem, because what do you think of when you think about a magnet? You think about refrigerator. Yeah, exactly. People don't realize that their smartwatches and their phones and their power tools and their laptops and their cars need these magnets. People don't understand that every aircraft and satellite and drone and missile and ship and submarine and tank need these magnets.
And it's not necessarily that they're crazy expensive either, right? It's just like you just need to have access to them in a reliable way.
Exactly. And when you put a rare earth element into a magnet, it's not your refrigerator magnet anymore. Two things happen. One, the strength of that magnet, the energy density, skyrockets. You have a much more powerful magnet with a much lower weight. So think speed, range, payload capacity. The second thing that happens when you use specific rare earth elements, heavy rare earth elements, the heat tolerance increases. So when we're putting this into applications that get really hot, that are operating under extreme pressures, your magnet doesn't demagnetize. And so we can talk about where are rare earths, what are the most important rare earths, but it is a three-legged stool. It's chips, it's batteries, it's magnets. And if we get that right, we're in a good place. If we miss any of those three, it's going to be really tough competing over the next couple of decades.
So let's dive into, when we do site selection, the three questions we have are people, power, and place as companies try to figure out where to build these factories. And it seems like a really unique opportunity for the country where the geography on where these projects are happening really is pretty broad. I mean, we're building batteries in Nevada and South Carolina, and aerospace in Utah and Tulsa. So you could do this stuff everywhere. The driving kind of question putting power aside, will be around talent.
Yes.
Are we properly educating and training a workforce to work in factories like this, to innovate and create these technologies? And if not, what needs to be done? What's your call to action to vocational training, educational institutions?
I think we're at the beginning, but there's a long way to go.
Yeah.
That is, frankly, the most important piece for us is our workforce. And so what I would say is there are complementary industries, batteries, there's aerospace, there's powder metal, where they understand how to operate this type of equipment. It's just in a slightly different way. I will be the first person to say the smartest people at this company, and the PhDs and the engineers at our company, like, don't take this the wrong way. It is our technicians.
Yeah.
They understand how to operate this equipment. They understand the nuts and bolts. Like, we need more people coming in and being technicians, going into the trades, being willing to, turn a wrench, but you also need to understand the software applications, right? And I think that
is that melding of software and hardware, which
software-enabled hardware, exactly. And I actually think that that's one area. So we're in the research triangle. They've done an exceptional job with the trade schools and the community colleges of having programs that teach people, hey, here's how you not just work a CNC machine, but here's a class on AI. Here's a class on automation. And so the answer is, I think we have the curriculum, and we have other industries that have started to build up over the last couple of years. We need a lot of smart people who are mission driven, frankly, to come in and do work like this, because it is service.
And let's talk a little bit about your educational background, right? So we're constantly kind of being exposed to these new technologies. And it's exciting because you're finding these CEOs who are coming out of Princeton, out of Stanford, out of MIT, out of Harvard. Talk about HBS, what that experience was like for you, and how these larger universities should be maybe even doing a little bit more to kind of get that talent base, thinking less about the consulting gig that would be easy to get if you walked out of Cambridge versus actually coming here, rolling up your sleeves and building stuff.
Yeah, I think it comes...
Because that seems like a big challenge from my perspective. It's like it's really easy to take the cush consulting gig when being mission driven and diving into this sector is a little harder.
I don't want to hate on the consultants. Those are hard jobs to get, and they work hard. But what I would say is I think it comes down to the curriculum, and it comes down to the professors. A lot of people go to business schools, or they go to these universities, and they don't know what they want to do.
Sure.
And when the only offering is, hey, you can go to a finance gig or a consulting gig, or go work at a big software company, all of which are great opportunities, they don't even realize that there are other industries that they can go into and potentially make a larger impact. So specifically, there was one class at Harvard Business School that was for people who wanted to get into hardware and tough tech and deep tech. It's called Tough Tech Ventures. It's taught by Josh Kriegler and Jim Matheson. And what that allowed students to do is actually find like-minded friends who are interested in everything from hardcore manufacturing to space to ag. And it allowed them to have actually a pipeline, not just from professors, but to companies coming to our classes who are looking to hire. And so I think it actually starts from top down, having professors and the curriculum and the support of the universities that say, hey, this is important, this is real, and there are industries that you can go and create that actually create the largest outcomes for the global economy over the next 45 years.
Well, look, just as we wind down, what I love about your career is when you were at the Pentagon, when you were at Navy Research, when you were doing your old kind of career, did you ever imagine having sat there studying the supply chain risks that we were already exposed to, and then coming out into the private sector and inventing technologies to kind of address some of those risks? I mean, it feels like an interesting kind of, perfectly natural segue, but I imagine 5-7 years ago, that wasn't probably on your radar screen.
That wasn't on the radar screen 3 years ago.
Yeah.
I never earnestly thought that I would be starting a company or being in this type of a seat. But when you get into the supply chains and you see a problem that you're losing sleep over, that has to be fixed, you just go and do it.
Yeah. And were you surprised more wasn't being done? That there weren't like 10 companies doing exactly what you're looking to do now?
I mean, there are a million reasons why this is a bad idea.
Yeah.
If you talk to any founder, any entrepreneur, any senior person at any company who is there at the early stages, there are 100 reasons why you shouldn't do something across every vertical, every major company that's worth billions of dollars today. You have to understand what those risks are, and then say, I understand what those risks are, and I'm going to do it anyways because this is too important to get wrong.
Yeah, that's amazing. John, thank you so much for hosting us, for being on Coffee with Ken. It was such a treat. I appreciate everyone tuning in. It's coffeewithken.com. You can follow us on YouTube, Spotify, and social media galore. Thanks so much.